Welcome to homework.
Hey guys, so in this question, we're asked to find balanced formation equations at standard conditions for each of these four compounds. So for the first compound, we have hydrogen iodide. So when we say we want them in standard conditions, that means these two elements, hydrogen and iodide, must be in their standard form. So hydrogen and iodide both exist as diatomic molecules and gases. So I'm going ahead and writing those down like that, and they are forming this compound. Now that we have that, we can go ahead and write in our coefficients to balance this equation out. So that would be 1/2 in front of hydrogen and the same in front of iodine, excuse me. And that is our final equation for this compound. Moving on to the next one, we have silicone tetrafluoride. We're going to do the same thing. So we'll write down silicone first, and as in standard state, it is existing as a solid, and fluorine exists as a diatomic molecule, so that's F2 gas. And that is forming our desired compound, silicone tetrafluoride, and that is a solid at standard conditions. Now we just need to put in our coefficients to balance out the equations. So that is 2 in front of fluorine, and now everything is balanced out. And that is our standard formation equation for this compound. For the next one, we have the formation of ozone. So that just comes from our diatomic oxygen gas forming O3 gas. And the coefficient that we need in front of the diatomic oxygen is 3/2. When we multiply 3/2 through, the 2's cancel out, and we're left with 3O, and that forms O3, which is ozone. And that is that final equation. And for our last one, we have calcium phosphate. And to do that, we have three elements. We have calcium, solid, being added to phosphorus, solid, and diatomic oxygen, gas. And that is forming Ca3, PO4, 2. And that is a solid. Now we just need to balance this out. So we have a 3 in front of the calcium, a 2 in front of the phosphorus, and a 4 in front of the oxygen. And that is our final equation for that compound. And now remember, for all of these equations and these standard formation reactions, the reactants are all going to have a standard formation enthalpy change of 0, since they're all in their standard states and their elemental forms.